Hi everyone, welcome back to PRAKASAM tutorials. In this video, I am going to discuss about bandwidth of the power density spectrum. The variance of a random variable is a measure of the average amount by which a random variable varies with respect to its mean. The positive square root of the variance is called standard deviation. It is a measure of the spread in the density function of the random variable. The probability density function of the random variable is always real and non-negative, and similarly the power spectral density also is always real and non-negative. So a new function is formed by dividing power spectral density of the random process by its area with the property that unit area is analogous to a probability density function. So that is fx of omega is equal sxx of omega divided by integral minus infinity to infinity sxx of omega d omega. So here Sxx of omega is the power spectral density of the random process x of t, and the denominator term is the area enclosed by a power spectral density. So the area enclosed by a valid density function is always unity, but the power spectral density curve need not have unit area always, and it can be normalized to have unit area. So that is the area enclosed is the denominator term. The area enclosed is integral minus infinity to infinity sxx of omega d omega. Okay, the power spectral density is always real and non-negative, and the power spectral density of the random process is also always real and non-negative. The normalized power spectrum behaves similar to a power density probability density function, and it is a measure of its spread that we call RMS bandwidth. So the RMS bandwidth expression omega square of RMS is equal integral minus infinity to infinity omega square sxx of omega d omega divided by area enclosed by the power spectral density. So this is the RMS bandwidth expression. The above equation is valid only for low pass random process x of t, that its spectral components are clustered near omega is equal to 0. For a band pass random process, the RMS bandwidth is given by omega square RMS is equal 4 into integral 0 to infinity omega minus omega naught whole square into sxx of omega d omega divided by integral 0 to infinity sxx of omega d omega, where mean frequency omega naught bar is defined as omega naught bar is equal integral 0 to infinity omega into sxx of omega d omega divided by integral 0 to infinity sxx of omega d omega. So this is the concept of bandwidth of the power density spectrum or bandwidth of the power spectral density.